In this video, we are going to learn how to graph polar curves. And my example is going to be the curve r equals 1 plus 2 sine theta. So that means I want to graph all points whose polar coordinates satisfy this equation. And so on this polar grid, and I want to, as I go along, I'm going to make a little chart of points to help me. So theta and r. But I'm also going to use the graph of the Cartesian equation, y equals 1 plus 2 sine x. Okay, so you want to think of x as your theta when we go over to the polar grid, and f of x or y is your r. So if I start with x equals 0, this gives me f of x equals 1. Right? So I'm going to start with theta equals 0, and I'm going to put that on my chart. And r would be 1 plus 2 sine 0, which is 1. And that corresponds to the point right here, 1, 0, right? Because this is, let me do that again, here. The positive x-axis is the ray theta equals 0, and I'm going 1 unit along it to the point whose polar coordinates are r equals 1 and theta equals 0. All right, so over on the left side, I'm going to look at the graph of y equals 1 plus 2 sine x, and let's just look at the part of the graph that corresponds to angles in quadrant 1 between 0 and pi over 2. So I see that when theta equals pi over 2, and that's also going to go on my list, r would be 1 plus 2 sine of pi over 2. Sine of pi over 2 is 1, so I get 3. So on my graph, theta equals pi over 2, that corresponds to the positive y-axis. This is theta equals pi over 2. And r equals 3 means that I should go 3 units along that axis, so that would put me here. And then when I look at the curve y equals 1 plus 2 sine x between theta equals 0 and theta equals pi over 2, it's increasing, right? So I want to draw my curve. So I'm looking at, I'm going through quadrant 1, right? So the angles between 0 and pi over 2 are those angles. And as I draw the curve in that quadrant, I should make it so that r is increasing from 1 to 3, so something like that. Get a little neater. All right, so now let's go to quadrant 2. So now I go look at the curve between pi over 2 and pi. So when theta is pi, I'll put that on my list, r would be 1 plus 2 sine pi, so 1. And pi, theta equals pi, corresponds to the negative x-axis. And r equals 3, so I'm 3 units along that axis on that point. No, I'm sorry, r equals 1. So I'm right here. Okay. And then again, I look at the graph of y equals 1 plus 2 sine x. I see r is decreasing, right? So I should draw my curve, and I'm looking at angles in quadrant 2 now, right? So right in here, with R decreasing from 3 to 1, so I draw it something like that. Okay, now on to quadrant 3. Now quadrant 3 is a little harder because when I go into quadrant 3, that's going between pi and 3 pi over 2, some of my r's are going to be negative because my curve goes below the x-axis, right? So let's first do the part of the curve where r is positive. So I'm just going to go from pi to this angle where I'm hitting the x-axis. So that would be where, let's see, so I just have to set r equal to 0 to find that. So, 1 plus 2 sine theta equals 0. That means sine theta is minus a half. And there's actually two angles that give me a sine equal to minus a half. One is in quadrant 3 and one is in quadrant 4. So right now we're looking at quadrant 3, and that angle would be 7 pi over 6. But later we'll need the other one, which is 11 pi over 6. So if I look at 7 pi over 6, that's that's this ray right here. So I'm going through these angles from pi, let's do it here, from pi to 7 pi over 6, and R is 0 there, and that's an angle where R is 0. So I'm going to end up at the origin. So, and R is decreasing right here, right? So I'm going to curl into the origin on that part of the curve through those yellow, through the angles in the yellow region. But now I've got to do the rest of quadrant 3. So now here's the rest of quadrant 3. And that ends at 3 pi over 2, so that goes in my list. And when I plug in 3 pi over 2, sine of 3 pi over 2 is minus 1, so r is minus 1. So now I'm going through these angles, but r is negative, so that means that I'm really going to draw the curve in through these, in that region, in quadrant 1. So I'm going to end, well, theta equals 3 pi over 2 is this ray. But because r is negative 1, the point is going to be 1 unit along the positive y-axis, so over here. And I'm going to be drawing my curve in the pink, through the pink angles in quadrant 1, so like that. All right, now quadrant 4, same kind of situation there. Part of quadrant 4 has negative r's, so that's this part right here. And that angle where I stopped is where r is 0, so that's the other angle that we already found. That is 11 pi over 6, and that would be this angle right here, this ray. pi over 6. But since r is negative, I'm really over on the opposite ray, but it doesn't really matter, right? Because r is 0 there. But I'm going through quadrant 4 angles. These angles. But since r is negative, I'm really going to draw my curve over here. And so it's going to go like this, ending at r equals 0 when I reach the ray opposite to 11 pi over 6. And then finally, the rest of quadrant 4 has positive r's, and that'll end at theta equals 2 pi. And r will be then 1. So that gets me actually back to where I started, right? That's this point over here. And for that part of the region, so I'm going through these angles, but r is positive, so I really do draw the curve in that region. So that's going to go like this as r increases from 0 to 1. And that is my curve. So it looks sort of like a heart with a little loop-de-loop inside.